solution? Do we just say x equals a number, y equals a number? No, how would we write the solution? We would write it like a point. Okay, so somewhere on here, I want you to write down that a system is 2 or more equations. A system is 2 or more equations. 2 or more equations. Okay? If you have 2 variables, you need 2 equations to solve the system. If you have 3 variables, you need 3 equations to solve the system. If you have 4 variables, you need 4 equations to solve the system. How many equations would you need if you had 7 variables? 7 equations. Okay. So this assignment, we only have 2 because I'm just trying to remind you guys of what you've learned before. So we're going to go ahead and start right here. It says that we have 2. These are in slope-intercept form. So I'm going to go ahead and write down the equations right here next to number 1. So y equals negative 1/2 x minus 7. Y equals 4x plus 2. So when we graph a straight line, do you guys remember if it's in y equals mx plus b form where we start the line? We start at the y-intercept, so this one's going to start at negative 7. So we're going to go down 1, 2, 3, 4, 5, 6, 7. Start at negative 7. And then where do we go from there? Yeah, so we do the slope of minus 1 over 2. So I go down 1, right 2, down 1, right 2, or you can go up 1, left 2, up 1, left 2. You just want to make sure that your slant is a negative slant. That's what you want to see. So down 1 to the right 2, down 1 to the right 2, down 1 to the right 2. When I'm teaching this to students who struggle with math, I tell them that the top of the fraction is what uses the sign. So if it's positive, it goes up. If it's negative, it goes down. And then I tell them that the bottom of the fraction always goes to the right. That's how I teach it to students who struggle. So this would tell you to go down, and this would tell you to go to the right. And if you do it that way, if you always go to the right, then you'll always have the correct slant. The only time I tell students to go to the left is if they've gone to the right and run out of space and need to get some more points. Then you can do the opposite pattern and go to the left. Okay, so there's our first line. And then what's the y-intercept for our second line? 2. So positive 2. Okay, and then what's our slope for our second line? 4, and I'm going to write it as a fraction. That's 4 over 1. So I'm going to go up 1, 2, 3, 4 to the right 1, up 1, 2, 3, 4 to the right 1, and I've run out of space, so I'll switch the pattern. I'll go down 1, 2, 3, 4, and left 1, down 1, 2, 3, 4, and left 1. And the nice thing about solving these graphically is typically as you're doing the pattern for both lines, you'll run into the same point. With the second line, you'll be like, oh, I graphed that point twice, and then that's the answer. So the point where these 2 lines crossed is left 2, down 1, 2, 3, 4, 5, 6. Left 2, down 6. Okay. So from the start, we're going this way. Okay, now flip the page over, go to number 7. I'm going to tell you what your 7th problem is going to be. Your 7th problem is going to be 3x minus 2y equals 4, and 5x plus 4y equals 36. And these are in standard form, so they are not ready to graph currently. So what do we do to get them ready to graph? You have to get the y by itself, and then we're going to simplify. So what's my first step to get the y by itself on the left side? Take the x term and move it to the other side. So I'm going to subtract 3x, move it over to the other side. I'm going to leave the negative 2y on the left side. And then on the right side, we're used to having the x term first. And so I'm going to write the negative 3x first, and I'm going to write the positive 4 second. So I'm closer to having the y alone, but I don't have it alone yet. What do I need to do to get the y completely alone? Divide by negative 2. So divide by negative 2, divide by negative 2, divide by negative 2. And then what is our equation? Okay, 3 over 2. Is the slope negative? It's positive, right? Because it's a negative over a negative, so that makes a positive. And then over here, the y-intercept is 2. Is it positive or negative? Negative 2. Okay. So we're going to start at negative 2, and then where are we going to go from there? Up 3 over 2. 1, 2, 3 over 2. 1, 2, 3 over 2. Now, normally when I draw lines, I wouldn't worry too much about doing all the points, but since I'm specifically looking to see where the lines cross, for this assignment, it's going to be helpful to have all of them, just because we don't know where the other line is going to run into this one. Or you could use a ruler to make sure that you have it perfectly straight. Okay, with the other equation, what should we do first? Subtract the 5x. So 4y equals negative 5x plus 36. Okay. Divide by the 4, get the y alone. So we've got y equals, what's our slope? Negative 5 over 4. And we've got the x on there. And our y-intercept is 9. Perfect. So we're going to start 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so it goes up to 10. That's good to know. Okay, so start at 9. And then we're going to go down 1, 2, 3, 4, 5, and over 4. 1, 2, 3, 4, 5, over 1, 2, 3, 4. So it crosses, is that at 4, 4? So it crosses at 4, 4. So if you look on your maze, this is the problem. Oops, there it is. This is the problem we just did. It's right by the hole punch. And there, 4, 4. Okay. were those two enough to jog your memory on how we graph straight lines? We remember how to do that? Okay. I'm not necessarily planning on doing all 4 worksheets today. We're going to start off with just graphing, see how long it takes us to get through those. Make sure that if you're rusty on this, you do ask questions so that you're comfortable with this material. If you were to be tested on it, you'd be able to do it. Okay? Sound good? Okay, so let's get started with this. I'm going to hand the test back. When you look at your test, make sure you look at the things that I've written on. Okay, so let's start this one. The first problem, y equals 5x plus 7, y equals 2x plus 4. This one is one you could definitely graph to solve, but we're not going to because they said to do substitution. So y equals 5x plus 7, y equals 2x plus 4. So substitution problems sometimes look like this, where they have isolated the same variable for you, and then they sometimes look like this, where one variable is isolated, and then you have another equation where they're not really like that. So these ones are kind of obvious with substitution because it's like, well, that y is alone, so I should clearly just plug that into the other equation. That makes a lot of sense for substitution. When they look like this, you're just going to set them equal to each other. So if I know that y equals an equation and y equals an equation, then those two equations should be the same, because y is the same variable, so it should represent the same number. So if it equals an equation, then the two equations should be the same. So what I'm going to do is I'm going to take this y and what it equals, and I'm going to substitute that in for this y, and I'm going to say 5x plus 7 equals 2x plus 4. So since they both equal y, they both have to equal each other, basically. And then it's just a simple equation to solve. So what should I do? So I'll go ahead. I heard somebody say subtract, so we can move the 2x over. So we've got 3x plus 7 equals 4. And then what could we do? Minus the 7, yeah. Yeah, and with these, there's a lot of steps you could do. There's not necessarily a correct order. There's a lot of different ways to get yourself to the same answer. And then what should we do? Divide by 3. Okay, so x equals -1. Now, how do we get the other coordinate? Plug it back in. So you're going to take the -1, you're going to plug it into either one of the equations. It does not matter which one. They're both going to give you the same answer. So you can plug it into the first one or the second one. I'm going to go for the second one because the numbers are a little bit smaller. So I'm going to say y equals 2 times -1 plus 4. That's -2 plus 4. So y equals 2. So my solution is -1, 2. -1, 2. Okay, let's go ahead and do this one real quick. So number 2, we've got y equals 2x minus 13, y equals -2x plus 23. So I'm going to set them equal to each other. And I'm going to get my x to one side. Or you can move your numbers over. It doesn't matter what you do first. move my 13 over. All right, go ahead and finish that one. Okay, so what did you guys get for x? X is 9. And then what equation did you guys plug the 9 back into? The first one. Okay, I would have done that too. So 2 times 9 minus 13 is 18 minus 13, 5. Perfect. Okay, so 9, 5. Okay, so that leads us to the other type of problem. So we're going to do one of these. Number 3, y equals negative 8x plus 2, 11x plus y equals 5. So here's the y. We know that y equals all of this stuff, and then here's a y right there. So I'm going to say 11x plus y equals 5. And then the y equals this stuff. So I'll go ahead and plug that stuff in for y, negative 8x plus 2. Now, sometimes the y is not alone. It's nice in this case because it was just a y. It wasn't like a 5y. It wasn't like minus y. So here there's nothing to distribute in front of the parentheses, but sometimes there is. So it's always good to put it in parentheses just in case. But here, for this particular problem, you don't really need the parentheses because the y did not have a coefficient. So the parentheses are a little bit unnecessary for this particular problem, but they are not always unnecessary. The next problem that we'll do, you'll need the parentheses. It'll make a difference. Okay, so what do we have on the left side? (3x plus 2 equals 5). And then we can minus the 2 over. We get 3x equals 3. And so what are you guys getting for your x value? 1. Now, just like before, we can always plug it into whichever equation we want. I pretty much always choose to plug it into the equation where the y is by itself, and that's just my preference. It doesn't mean you're going to get the answer wrong if you use the other one. It just comes down to what you prefer. So I'm going to go ahead and use the first one when I plug it in. So I'm going to say y equals negative 8 times 1 plus 2. And so what would the y coordinate be? Negative 6. Y equals negative 6. So the x coordinate is 1, the y coordinate is negative 6. And we're going to do this one last problem together, and then I'll let you guys work on the rest. So this is the one we just did. It goes over here. Okay. So the fourth problem, y equals negative 9x minus 29, 10x minus 11y equals negative 8. Okay. So the first one, the y is already isolated. That means I'm going to be plugging it into y for the second one. So I'm going to start off by putting a parenthesis where the y is. So 10x minus 11, there's where my y is, equals negative 8. And then if this is what y equals, then I'm going to be plugging it in right here. So negative 9x minus 29. And this is a problem where the parentheses matter. If we didn't put the parentheses, we would have gotten the problem wrong. So what should I do first? Distribute the negative 11. So negative 11 times negative 9x. What did you say? 99. So plus 99x. Negative 11 times negative 29. Everybody has a calculator. $119? 319. Okay, so plus 319 equals negative 8. Okay? Now what do I do? Combine like terms. 10 plus 99, 109. Okay? Plus 319 equals negative 8. Okay? Now what should I do? Subtract. Minus 319, minus 319. So 109x equals negative 327. And then what should we do? Divide. Negative 3. X equals negative 3. So you can plug it into whichever equation you want. Which one would you guys like to do? The first one, the y is already isolated. That makes it a little bit easier. So negative 9 times negative 3 minus 29. So we've got 27 minus 29 is negative 2. So negative 3, negative 2. Okay, there we go. How do you guys feel about the substitution ones? Unrusty? Unrusty, perfect. Okay, so for over the weekend, for tonight, we are only going to do the first sheet front and back. That's it, okay? Graphs are shown on the graph paper. This work is shown on this sheet of paper, okay? Perfect.